Greetings to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So we are finally back to our regularly scheduled programming. I hope you all enjoyed the past 3 weeks of the kind of greatest hits, or the core modules as I'm calling it. And I got the idea that I should continue this trend, and rather than kind of stocking up years worth of these core modules, release them on a more, frequent basis and just kind of keep it as an ongoing thing, which definitely would make my life easier because it was, you wouldn't think trying to make a compilation thing of like your best clips would be that difficult. And to be honest, it really wasn't, but it's quite time consuming that I found out. So having those kind of there and then just kind of working forward from that will probably be easier for future ones. But with that all said, I hope you all enjoyed your holidays, and hopefully you got to take some time off from work if you work, or if you're in school, hopefully, I would hope, or you should have at least, got some time off from school and got to spend time with family. I know I got to take some time off for work and spend time with family and definitely enjoyed it. So hopefully you all did as well. So let us get into our trivia question for the week. So this week's trivia question is, how many terabytes are there in an exabyte? So how many terabytes are there in an exabyte? And that is your trivia question for the week. Now, I did say this was going to be a regularly scheduled episode. However, unfortunately, the cybersecurity tip for this week does not apply to you, the listener, unless, of course, you, the listener, are the person who I will be addressing. But for the mass audience, unfortunately, this does not apply. But this really needs to be addressed. So without any further ado, let's get into this week's cybersecurity tip. So as I alluded there, this individual or organization in particular, aka hotels, please put your listening ears on for this one, because you really need to start verifying people's credentials. So, a few months ago, I told you all a story of how bad the security was at a hotel I was staying at, and how I basically could have gained access to any single room in the hotel that I wanted to, basically by just giving them my key card and saying it doesn't work, but this is my room number. So if you want to hear the full story to that, the episode was titled "I'm Not a Pen Tester, But..." So if you want to hear that full story, go listen to that after this episode. But hotel security continues to disappoint me. So, like most people, I think, I was doing some traveling for like Christmas and New Year's, and as such, me and my family were staying at a hotel while we were visiting some of our extended family. And my family happened to get locked out of our room because we had 2 keys for the 4 of us. And we all assumed that everyone else had a key, so we didn't bother taking a key, so we got locked out of the room. Common mistake, but then my mom decided that she was going to allow us to get back in the room, so she went to the front desk to request a new key and got absolutely no questions asked, received said new key. So sure, she had to give her name and the room number we were staying in, but there was no verification of her identity at all. They just asked her for her name and room number, and then I would assume they did maybe a quick lookup to see if that name was tied to that room, saw it was, and then just made the new key. So, in theory, if you did a little social engineering or eavesdropping, you could easily figure out someone's name and the room number they were staying in, and bingo bango, you got access to their room. Now, combine this with my little key doesn't work, can you recode it exploit from previously. You basically have now got access to any single room in the hotel, and you literally could have just been some bum off the street that just happened to, casually be loitering around the hotel acting like you're actually a resident, when in reality you're just trying to gain someone's credentials through either eavesdropping or social engineering in some way, and then getting access to their room or any other room in the hotel. So hotels, please do a better job of verifying people before you just blindly give them a key card to a room in your hotel. Please and thank you. And that is, well, not necessarily your, but hotels, their cybersecurity tip for the week. So technically, with the episode of the title of this episode, I guess pretty much the rest of this episode is really an entire nerdy things segment in and of itself. But I figured I would at least split it up some and kind of keep the book stuff at the end kind of in its own separate thing, and then do our usual thing of talking about nerdy things. So I guess with that, let's just get into what nerdy stuff have I been up to this week. So I recently upgraded my M4 Pro Mac Mini to macOS Sonoma 15.2 and got access to the glorious Apple Intelligence. Hopefully you could tell the sarcasm in my voice there. Now, naturally, I had to ask it some very basic questions. That, of course, being how good was it at writing code? And Siri's response was, quote, "Sorry, I can't do that." And I was like, okay, maybe if I be a little more specific, Siri will be able to give me a better answer. So then I asked, how good are you at programming? The response, sorry, I don't understand. So we're not off to a good start here, folks. So then I asked, how good are you at software development? And the response was, I can use ChatGPT to answer that. Oh boy. Now, granted, I was just using the generic Siri interface. I wasn't doing any kind of like Xcode, like code completion, AI assistant thing in there. So that probably would have given some better results. But yeah, just the generic Siri asking it kind of coding things was pretty rough. Now, what I didn't test, which actually could have given some better results, is just asking specific coding questions. So rather than saying, hey, are you able to write code, ask like, hey, how do I write a for loop? Or, hey, I'm experiencing this bug in my code, can you fix it? Then I might have been able to get some better results, maybe, I don't know. Or it might have just given the old, I can use ChatGPT for you, which is not what I wanted. But the other thing I also tried out was Image Playground. Now, I didn't go super deep into this, but one thing I did, which probably will surprise no one, is I asked the Image Playground to basically for an image of a data center like server rack in a living room, and it actually gave a pretty decent output. What would be interesting would be to give the same prompt to the Image Playground as well as the Stable Diffusion instance I have running, and kind of compare notes, compare results, see what they output. That sounds like a pretty great idea for a future Nerdy Things segment, but unfortunately, I only thought of that right now as I am speaking this episode, so it will not be for this episode, but maybe for a future one, if I remember. But then getting into some other things I did, I also worked on my video game some, and over the past few weeks and months, I had been working on this whole like config file system to allow you to manually configure various settings like the buttons and the screen size and all that good stuff. And since the screen size is now configurable, I quickly discovered that my text alignment, as well as a couple other things, doesn't exactly scale the best. So I went through and updated how I align text and kind of updated the whole scaling thing and how it works, which, if we're being honest, I knew this was an issue and needed to be addressed sooner or later, and I guess this week just happened to be later. And as Jeff Geerling put it, whenever you unearth something, you notice all the little bugs crawling underneath it, and that's basically a fantastic summary of what happened here. I noticed I was going to unearth the screen size resizing issue of various text and other things, and then noticed all of the various bugs and issues that underlied it. And so that took up a decent amount of my time this week. So most of it was basically just fixing these scaling issues, and I got a lot of them fixed, I think, in order to fix the overall larger problem. Now, I'm sure there's probably some that I missed or kind of overlooked, but things are definitely looking a heck of a lot better now. Things not only look better just in general, but they also scale a lot nicer when you resize the window, which is really nice. And one thing I haven't fully decided on is how I'm going to handle window resizing. So currently, you can just drag the corner of the window to make it whatever size you want to a certain point anyway. But one thing I was thinking of doing was not allowing you to do that, but instead kind of do what some other video games do, and in some kind of settings menu, you can select what screen resolution you want. So I can essentially pre-can resolutions that I know are going to look good, and have those as the predefined defaults that you can select between. And then when you click on one, that will automatically do the resizing for you. And you can't do it by yourself. So kind of throwing that around. I'll probably implement that, see how it works, see if I like it, and then kind of go from there. Or maybe I'll allow you to do both. I don't know. We'll see. But the other thing that I did was something that I had wanted to do for months. So before I started on this whole config options thing, writing the config file to allow you to, manually change settings in that way, I wanted the user to be able to view not only the Pokemon stats, but also to be able to view their IVs and their EVs, or their independent values, or individual values rather, and effort values. So if those are foreign to you, essentially what that means is in Pokemon games, every Pokemon has what's called individual values, which are basically values that you can't change and are set between 0 and 31 for each one of the different stats, and it determines basically how good your Pokemon is in a certain category, like how good its attack is. So this kind of gives you that variability in nature that some, animals in a certain species are taller than others or stronger than others. That's kind of where this comes from. And then the effort values is kind of like your environment. So just because, you might not be as naturally gifted in something, if you train and practice a lot on that specific skill, you can get better in it and compete with someone that is, more naturally gifted in that way. And that's essentially what these two different values are trying to do. But even in the modern games, at least in my opinion, they don't do a very good job of telling you what these values are. They have gotten better over the years in some of the more recent generations, but they just kind of give you a graph, and if you don't know what you're looking at or looking for, it doesn't necessarily make a whole lot of sense. So what I wanted to do was just allow the user to toggle on the stat screen between the actual stats as well as the EVs and the IVs, so they can see all of those to actually see how good their Pokemon is, and if they do want to do some kind of EV training or something to train a specific stat, they can more easily track that rather than trying to do a bunch of guesswork and calculating things by hand or using some other tool. They can just see it inside the game. So that's one thing that I've wanted to do for a while. But like usual, I got sidetracked with other things from, implementing the user config options to updating scaling, writing a script to generate Xcode projects, the usual things that happen when I get into something. Some, side thing happens upon me and I just figure I'll implement that real quick, and then that ends up taking a lot longer than I think it will. And then, things just get sidetracked and things get put on the back burner. And then I finally get back around to doing the thing that I originally wanted to do. Anyway, finally got around to doing that. And what was nice about it is this was one of those features that I was actually able to implement quite quickly. Now, there was a little extra work that went into it just because I realized that how I was doing some of my setting of the EVs and IVs and my Pokemon constructors, as well as those functions themselves, did need a little bit of tweaking, but that was kind of its own separate thing. The actual implementation of getting the ability for the user to toggle between the IVs, EVs, and the stats was honestly pretty quick, and I think I was able to get it knocked out in like either 30 minutes to an hour or something like that. It was pretty quick, so definitely pretty nice to see there. So now let's get into the actual point of this episode, which is nerding out on nerdy books. Now, from the start, I have honestly not been one for reading. And most of my life, I didn't like it at all. Like, I would purposefully try to avoid reading at all costs. And personally, I attribute this to English classes forcing me to read books, plays, and other pieces of literature that I had absolutely zero interest in. Plus, if you've listened to the podcast for long enough, you know my stance on schooling in general. And if I'm forced to do something, I pretty much already don't like it. Even if it's something I actually have an interest in, I'm not going to enjoy being forced to learn about it. Which is why I picked computer science as my major. Well, one of the reasons why I picked computer science as my major in college was because I liked it enough that I could at least tolerate the fact that I was being forced to learn things. And I could still kind of do other things on the side to make it a little less painful, I guess. I don't know if that's the right, description, but I'm going to roll with it anyway. Anyway, you add on top the fact that I don't like the thing that I'm being forced to do, and yeah, you can kind of see why things aren't going to end up very well and why it'll leave a bad taste in my mouth. Now, one of the main gripes I had, in addition to just quite honestly not caring, was the tests and quizzes. Because at least in my experience, they tended to ask these. They went for like a couple different angles. One of them was either they asked like uber specific questions about minor details that even if you genuinely read the book, passage, chapter, or whatever you had to read, you would have trouble remembering those details. The other one, which was probably even more annoying, at least in my opinion, were the opinionated questions. And when I say opinionated questions, these are the classic, which of the following best describes, or which of the following most exemplifies, or which of the following is not one of, maybe not that last one, but these things that kind of are more, they're not like which one is the correct answer. It is a kind of which best fits, which depending on how you want to make the argument, there's usually at least 2, if not 3 answers that you could make an argument for why they are the best, which is another reason why I like, some of the more sciencey based classes, because there is a right answer. You either have it or you don't. There's no ambiguity here. And even in like computer science and programming, you can, write the code in multiple different ways, but at the end of the day, your output should be the same. Now, the only kind of catch there is if you're part of the requirement for, your output is you have to meet maybe some kind of like time restriction, or you have to write in, a certain big O or something. Like you have to have so much optimization in order to meet some kind of other requirement. But we're kind of getting off topic here. Back to where we are with these opinionated questions. So, these are, like I said, which of the following best describes, that kind of thing. So, one of the classics would be something like, which of the following best describes what the author's intention was when telling us the protagonist was wearing a blue shirt? Which, for the record, who are you, the teacher, professor, or whoever, who are you to say what the author's definitive intention was unless A, you are the author, or B, you ask them directly? And I know darn well you are not William Shakespeare, and you definitely were not able to ask him what he meant in a certain passage of dialogue. Another thing, who's to say that your interpretation is the only correct one? And why am I wrong because I interpreted it differently or got a different meaning out of it than you did, or I didn't think a specific detail was as important as you did? Because at the end of the day, you're back to the point about you're not the author, and only the author truly knows what their point was or what the actual significance of something was. The only one who can say definitively is them, and everyone else is basically speculating at this point. So, yeah, tangent aside, I guess tirade aside is probably the more accurate term. About a year and a half ago or so, shortly after I watched the Ready Player One movie for the first time, which I talked about in one episode we did, I believe it was episode 69, which was a pretty nice episode. And I picked up the book and the sequel and read through them. So there, in case you didn't know, the Ready Player One movie was, I guess, very loosely based off a book of the same name, Ready Player One, and there's also a sequel to the Ready Player One book called Ready Player Two. And technically, I guess the first one I listened to like through an audiobook, but if you wanted to argue with me that listening to an audiobook does not count as reading, I did ask an authoritative source on the subject, that being someone who works at a library, and they assured me that listening to audiobooks counts as reading, so checkmate. The second book, Ready Player 2 that is, made me do something I had not done in ages, and that was actually sit down and read. Because when I read through the first book, I just kind of did it, just kind of listening to it while I was kind of doing other things like walking or something else, and kind of listening to it passively while also paying attention to it. But the second book, I genuinely, I would do that as well, but then I would genuinely sit down, stop, not do anything else, pick up the actual book itself, because I also had the book as well as the audiobook, and read along with the book as I listened, to the audiobook. And it was something I had never done in I don't know how long, and basically I just didn't want to put the book down because I wanted to see how things would go. Now, all this preamble to say, last year around the holidays, I decided to reread the books, and then this year I also decided to reread them again around the holidays, unintentionally starting a tradition of rereading them around the holidays. And as I did that, I just kind of wanted to dive into some of the moments in each of the books that I liked. Now, with that said, I should note, and it probably should be obvious, because I'm talking about both of the books, there are major spoilers coming up for both of the books. So you have been warned. If you don't want either of the books spoiled, probably don't listen to the rest of the episode, and maybe come back to it once you have. But with that spoiler warning aside, let's start off with the first book, Ready Player One. So the first thing that I wanted to address was the data transfer speed that goes on in the book, kind of in the latter half of it. So the quote specifically from the book was, quote, "Even using the plug's high bandwidth fiber optic connection, the total estimated upload time for 10 zettabytes of data was over 3 hours." So if that made no sense to you, that's okay, because we're going to break it down. So the core thing to pull out of that was being able to transfer 10 zettabytes of data in over 3 hours. So less than 4, but more than 3, you're able to transfer 10 zettabytes worth of data. So what does that even mean? Well, let's break it down. So we all know what a terabyte is, right? It's 1024 gigabytes. So if you want to get to the next level, that would be a petabyte, which is 10,024 terabytes. And then if you want to get to an exabyte, that would be 10,024 petabytes. And then to get to a zettabyte, that would be 10,024 exabytes. So that would be essentially 10 times 10 to the 24 and, to a certain power for whatever denotion you want. So what we can do to actually figure out the transfer speed, which I guess I should mention, 10 zettabytes is an absolute boatload of data. Now, the funny thing is you'll hear people talk about like either in home lab spaces or data centers, talking about like a petabyte project where they essentially try to assemble a petabyte's worth of storage, whether that's in hard drives or SSDs or something like that. And that is like a massive undertaking. And we kind of established here that just a singular exabyte is 10,024 petabytes. And then you have to take another 10,024 of those exabytes to create a single zettabyte. So we're talking an absolute massive amount of data here. And you're able to transfer all of that in 3 hours. Or I guess just over 3 hours, or over 3 hours is the actual quote. So what we can do is we can plug those numbers into Omni's data transfer calculator, which unfortunately they don't allow you to give zettabytes or even exabytes for the units. But what they do allow you to do is give petabytes, which is why we kind of went through, which is one of the reasons why I gave that kind of context going through the different conversion rates. So what we can do is if we convert those 10 zettabytes to petabytes, that gives us 10,485,760 petabytes, or essentially 10 to the 24 squared times 10. And then we give the time frame for how long this data transfer will take place, which I gave the estimate of 3 hours and 15 minutes. And that gives us roughly 7.17 billion, that's billion with a B, gigabits per second. Now, converting that into a smaller number, that would be approximately 6.68 exabits per second. So you heard me right, exabits per second. So imagine the travesty that you'd have to endure of having to put up with only 6.6 exabits per second as your internet connection speed. Now, when we talked through some of like our networking episodes, one of the at the time, kind of the biggest, fastest switching capacity switches were able to do like, I think it was 400 gigabits per second on a single port. And then recently that's come out that they're able to do like 800 gigabits per second. And here we're talking in the billions of gigabits per second. So there currently are not any switches that would be able to handle that, let alone any kind of, I don't even know if any kind of CPU or RAM or memory or anything like that could handle those kinds of speeds. But those are the speeds that we're talking about, and I just thought that was absolutely incredible and mind-blowing and wanted to break it down. Now, I did mention that the time span I gave was 3 hours and 15 minutes. And I wanted to give a little bit of a rationale for why I picked that. So I figured that the language that that was used in the book was over 3 hours. So to me, that puts it around the 3 hours and 15 minute mark, since if it was closer to 3.5 hours or more, I believe the author would have said so, because if it was more like 3 hours and like 20 minutes or 3 hours and 25 minutes, at least if I was writing that, I would say it took almost 3.5 hours rather than it took over 3 hours. And kind of in the same vein, if it was closer to 3 hours on the dot, it probably would have been something to the effect of just over 3 hours. So that's why I went with a 3 hours and 15-minute mark. But again, this is pure speculation on my part, kind of going back to the whole tirade I went on earlier. So that could be completely wrong, and I could be completely out in left field. But the point still stands that it is an insane amount of bandwidth for a single connection. The next thing I wanted to touch on in the same book actually comes prior to this data transfer speed, and that is all of the various hacking, lateral movement, and backdoor shenanigans that goes on in the book. So in the book, the main character, Parzival, aka Wade Watts, goes on the Oasis's version of the dark web, and the Oasis is kind of their whole like virtual reality it's basically the entire internet to them. So he goes on that version of the dark web and buys a series of passwords, exploits, and backdoors for IOI's network. And IOI is essentially like a big multinational conglomerate that is trying to take over the Oasis. They're like the evil bad guys, and they basically control a lot of the world's internet infrastructure, as well as like various gear in order to allow you to access the Oasis. Anyway, this leaked info that Wade was able to download was from a former IOI contractor that designed the network. But the catch here is the only way that you could perform these exploits, backdoors, and use these passwords was if you were inside the network itself. So this section of the book is one of the best examples of an insider threat that I've ever read. Now, granted, I haven't read a whole lot of books on insider threats, so there might be better examples. But, the point here is this book wasn't meant to, depict, and being a prime example of an insider threat, yet it does it so well, at least in my opinion. So Wade, who at the time was assuming a false identity as Bryce Lynch, what he does is he buys this this data from the dark web, but the way he's able to assume a false identity was a separate time he bought data from the dark web in order to access the citizen registry to essentially create a bogus identity and give him that identity. Since how the citizen registry works in the book is it takes your retinal patterns and fingerprints, and that associates you to whoever you are as a citizen. So what he basically did was create a fake identity, copied his prints and retinal patterns to the fake identity, and then when he wanted to go back to being Wade Watts, he just kind of reversed the process. But also during this time, he also modified his financial records also through this, password or exploit that he had to the citizen registry to basically say that he was indebted to IOI to force them to bring him into indentured servitude with the company until his debt was paid. So that allowed him to get access into behind the company firewall and into their network. Then, after all the various processing stuff was done, he gets to work by hacking them. So essentially the first thing that he does here is inside their hab units, or their sleep pods, they have like an entertainment console that they can not do a whole lot with, but they can do watch some corporate approved things and whatnot. So essentially one of the passwords that he got from the leak was able to give him admin access to the console. And then from there he was able to perform another hack which would show pre-recorded footage of his ear monitor as well as the camera in the hab unit rather than showing a live feed, so he could hack IOI in peace. Pretty fantastic. But just because he had access to the entertainment console, it only gave him so much room in the network, which is probably a good practice by IOI, right? You want to make sure your network is segmented. But because he had admin access, he had just enough room to create a bogus admin account, which would allow him to then hop to other portions of the network to dive deeper into things and exfiltrate a bunch of different data. And and basically get free reign over the network. So, using the various exploits and stuff to create a bogus admin account and then laterally move throughout the network. So in addition to creating the bogus admin account, what he was also able to do was create like bogus ticket requests. So this was where he was able to get that 10 zettabyte flash drive that we referenced earlier in the data transfer thing, as well as a maintenance tech uniform that he used for his escape plan, and then the munitions request that ends up blowing up the wizard operating the artifact that was holding up the shield around the third gate, which was basically the main reason why he went through with this whole plan in the first place, was to find a way to deactivate that shield and allow him and his friends to access the third gate. But then he hit a roadblock when he was exploring their database info. So what he did was he created another bogus account, literally called a test account, with super user privileges in order to access it. Then, once he exfiltrated as much data as he could off the flash drive, he then had to accelerate his timeline, so he used the various bogus accounts he created to laterally move through the network to modify his indent profile within the company's network to basically zero out his balance so he could make the escape. So that was a lot, but to recap, he hacks his entertainment console, then with the limited capability that granted him, he created a bogus admin account so he could then laterally move throughout the network with basically as much privilege as he wanted, and then when he hit a roadblock, he could use that admin account to create another bogus account with super user privileges to get to the various things he wasn't able to access prior to that in order to exfiltrate a bunch of data, which then kind of comes back to bite the company because then they get burned by it, all the data that he got off from them. So yeah, this is basically the definition of an insider threat, and really one that you really would not expect. I mean, I think probably if I could put myself in the mindset of IOI here, probably the last thing and last place they would expect to get hacked from was one of their indentured servants through a locked down entertainment console. So yeah, I think this just kind of goes to show why, insider threats are definitely a serious thing, and why you should, one of the reasons people like to implement, zero trust policies is for this exact reason. You shouldn't be trusting anyone on the network, even if they've already been previously authenticated by some other means. Just having a policy of zero trust can at least help mitigate, the risk of some of these things like this from happening. Now, the next part is actually from both books, but also kind of in the spirit of cybersecurity is kind of in the same vein, and that is the big red button. Now, the big red button is also in the movie version as well, but because we're talking about the books, I'm just gonna stick to the books for this. So the big red button is a button with the word off on it, and it serves a couple of purposes. The first purpose is it completely shuts down the Oasis, and the second purpose is it launches a worm to destroy all the code, servers, backup servers, so the Oasis can never come back online. Now, before we get into the craziness that is that second point, let's address the first, point and a half, and how easy that would be to actually implement if you were actually trying to write this code yourself. So I think the first one is pretty obvious, right? Shut down the Oasis if the button is pressed. Basic if statement. If button is pressed, do action. So if the button is pressed, this kind of gets into the first half of that second bullet. You launch said worm program, which assuming would be lying dormant somewhere. And then when the button is pressed, you use some code to launch said worm, and then you shut down the game, the Oasis, however you want to do that, exit the program, however it ends up being, you shut it down. But now let's get into the fun stuff, diving into how this theoretical worm actually works. Now, first off, you have to have written one heck of a back door that no one would have noticed or have taken advantage of previously in order for you to deploy a worm to instantly take down everything. Now, whether this is a backdoor or some 0-day that Halliday, who was the creator of the Oasis, has been kept under wraps from everyone and no one happened to notice, which, to be honest, I find a little hard to believe, in the sense that in the books, the Gregarious Simulation Systems, or GSS, which is essentially the company that created the Oasis, is essentially like the modern day FANG companies if you put them all together. In other words, they basically house the best of the best developers, like the cream of the crop. And if you mean to tell me that none of them could find this hidden backdoor in the code all this time, I'm not sure I buy that. I mean, I guess there's the chance that when Halliday, created the big red button, that was the original intent, and as far as he knew, it was still able to work in that sense, but has since been patched. I mean, I guess that's a possibility. The book doesn't really go into that. But the other thing that's interesting is, even if we assume that the backdoor or 0-day or whoever this worm is going to be spreading still exists, the other intriguing thing about this is, how do you actually guarantee that everything actually gets destroyed? And in order to kind of answer that question, I think we should kind of dive in more specifically on how the worm would actually work. Now, these are kind of my assumptions just from the overall principles kind of we established of how a worm gets unleashed and will destroy essentially all the Oasis, take down all the backup servers, and destroy all the source code. So here's my assumption of how the worm actually will work. So when the worm gets unleashed, it exploits some sort of backdoor or 0-day vulnerability to infect itself on all the servers running the Oasis and then delete everything. Simple enough. But similarly, the worm would also have to target any system that hosts their version of source control, which I'm assuming they're using some kind of version control for the Oasis, I would assume. So it would have to identify all of those systems as well, perform some other backdoor 0-day something, and to get onto those systems and then delete them. All the version control to delete the source code. Then it would also it also makes mention in the book that it destroys all the backup servers too. Geez, how many 0-days are you exploiting here? So since it has to get onto the backup servers as well, it would again have to use some kind of 0-day exploit or backdoor or something to get onto the backup servers and then wipe everything there. Now, I guess, if, since the book says Halliday, the creator of the Oasis, is like this mad genius, like super guy that, could basically do any kind of coding thing that he wants and it just happens, I guess it's also possible, if he created the entire Oasis, he also created the version control system that they're using. So essentially they're not using Git or, SVN or any of those others. They have their own separate version control that Halliday created. And then also whatever they're using, whatever software operating system their backup servers are running, Halliday also programmed, in which case he could have, programmed some kind of 0-day or backdoor that only he knew about and his worm would use to exploit in order to gain access to these systems. So that's kind of my general guess and assumption of how this worm would actually work, if assuming all this world was actually real. So, but the main issue is, if one of those, what would happen if one of those backup servers just happened to be down for some kind of maintenance or something? Then the worm, when it got unleashed, wouldn't actually be able to destroy everything because one of the servers was down. Now, the countermeasure to this, for the worm's perspective, would be the worm never dies, because essentially once the worm infects the system, it just always is there, whether you do some kind of rootkit embed or you kind of embeds itself in kind of like the bootloader or firmware or some like low-level place where it's a lot harder to get rid of. Essentially, the worm never dies once its main goal is done, just for in the event that some other Oasis system comes back online, it can then go and infect that system and then destroy it as well. So basically, the worm just kind of sits dormant, scanning the internet for future copies of the Oasis in order to infect and destroy them. So that's kind of my interpretation of how a countermeasure would work to ensure that even if, like, say, a backup server or an Oasis server was offline for maintenance, it would still end up being destroyed anyway, because the worm would just lie dormant amongst all the other systems that existed, and then once that system comes back online, boom, the worm infects it and takes care of it. But what about a standalone copy? Because in the second book, they make a scaled down version of the Oasis that they call Arcade, and it's basically on their spaceship and is completely separate from the Oasis. And they even make a mention in the book that they were able to completely sever the connection between the Oasis and Arcade, essentially making them completely inaccessible from one another. So you could kind of think of this as, like in your home network, if you have a bunch of computers connected to a switch, they can all talk to each other and, network together. But they can also get out to the internet, assuming your router is plugged into it. But then if you unplug the router, those systems can't access the internet anymore, but they can still, talk to themselves because they're on their own standalone network. So in this case, if someone were to have a completely separate standalone Oasis that the worm would never be able to access because it's completely offline, then this kind of brings up the question again of how can you ensure that the Oasis is completely destroyed by using this worm, because there could be such a case where there is just kind of a standalone, completely separate version that is completely offline that the worm would never be able to access. So interesting to think about. At least I thought it was. So now that we kind of talked about the first book and kind of the overlap between the first and the second, let's get into the second book, Ready Player 2. So the first part that I wanted to talk about here actually has nothing to do really with computer science, although it kind of sort of does with how I went about solving it. So I've talked before how back in the day I used to love to solve a good physics problem, the things like projectile motion, time dilation, those kinds of things. So this inspired me to, write computer programs in a sense as kind of wraparounds for these functions so I could solve them more efficiently, much quicker, and, more of them. So I was intrigued when the book dropped this little tidbit about being able to travel to Proxima Centauri in their spaceship that they're developing and being able to reach Proxima Centauri in around 47 years or so. So if we take 47 years to reach Proxima Centauri, my research told me that Proxima Centauri is around 4.2 light years away. So if we do all the math and calculate it, we would need to travel at around 9% the speed of light in order to get to Proxima Centauri in 47 years. Now, this, for all of you questioning my math, like all the physicists out there, let me walk through things just so you kind of see how I came up with that 9% number. So we take 1 light year, we multiply that by 4.24, because Proxima Centauri is 4.2 light years away, and we get a very large number, which is over 40 quadrillion meters, or in English for us Americans, that's around 25 trillion miles. So we take 47 years and we convert that to seconds. That gives us approximately 1.5 billion seconds. So then to calculate the velocity, we take the distance divided by the time. So that would be our 40 quadrillion meters divided by our 1.5 billion seconds. And then we take that velocity number and we divide it by the speed of light and then multiply that by 100, so we actually get the percentage, and that gives us roughly 9% the speed of light. Now, if we plug that into my time dilation calculator that I created, traveling at around 9% the speed of light While for the passengers on the spaceship, they would age 47 years, those still on Earth would have aged around 47.2 years, or about 10 weeks more than those passengers on the spaceship. Now, granted, I am just a code monkey who occasionally breaks stuff in his home lab and not a physicist, so any physicists out there in the audience, please feel free to correct me if my math is wrong in any way. So that one I just thought was kind of fun because it kind of took me back to some of the early roots of what I got up to when writing programs. The next one I wanted to touch on, which I think is probably the last one we'll get to for this episode, is in the book, they very nonchalantly make a comment that they added 1 million yottabytes to their, storage capacity. And I figured we should probably dive into the math behind that because the book like I said, it so nonchalantly just makes the comment, yeah, we just added 1 million yottabytes. Like, no big deal. Now, granted, this book takes place in the future, so like we see in present day, every single year, more storage becomes available for cheaper prices. It gets more dense and becomes cheaper. So let us go back to our context from the first portion we did, which was that data transfer calculation. So we will recall that 1 petabyte is equal to 1024 terabytes. 1 exabyte is equal to 1024 petabytes. 1 zettabyte is equal to 1024 exabytes, and 1 yottabyte is equal to 1024 zettabytes. So we are talking a massive amount of data. Then you have to multiply that by 1 million because we have 1 million yottabytes. So according to TechRadar, the largest storage device on the market as of right now is the Exadrive EDDCT100 by Nimbus Data, and TechRadar claims the retail price is $40,000. Now, I was not able to independently confirm this since Nimbus Data's website doesn't list the price because I'm pretty sure it's one of those things, if you have to ask, you can't afford it type things. So in theory, you could also get away with smaller drives that would have a better cost to terabyte ratio, but then you would need more of basically everything. You would need more servers to stick said drives into, and you would also need more server racks, and because the scale we're talking about, you would need more data centers. So I didn't do the math because I don't know how much it costs to build out an entire data center or what servers you would be selecting to stick all these drives into. So I didn't do that math specifically, but I did do the calculations of how much it would cost, at least with today's technology, to get 1 million yottabytes. And spoiler alert, it's mind-blowing. So in theory, you could get away with, smaller drives, which would be cheaper, at least in terms of the drives. But again, because of the amount of drives we're talking about, there is the potential chance that with the cost of all the data centers and servers, it may even out, it may not. Like I said, I didn't do the math on that, but it is definitely something to consider. So for context, the largest hard drive, at least soon to be, is 32 terabytes from Seagate. Now, currently there's no price for that, and you can't buy them, at least as of the recording of this episode. So our next best thing is a 24 terabyte drive, and you can buy those for roughly $479.99 a pop. And the reason why I point out the 99 cents there is because on the scale of sheer number of drives we're talking about, that 1 cent will definitely make a difference in the long run. So let's start off with the 100 terabyte SSDs calculation. So in order to get to yottabytes, we have to take 1024 to the power of 4 in order to convert terabytes to yottabytes, and then we have to multiply that by 1 million because we have to account for 1 million yottabytes. So that gives us roughly 1.1 quintillion terabytes that we need to account for. So if we divide that by 100, because each of our drives has 100 terabytes, that gives us roughly 11 quadrillion drives that we need to purchase in order to get to our 1 million yottabytes. Now, if we multiply that 11 quadrillion by $40,000, that gives us roughly $439.8 quintillion just in drives alone. So that's not including servers, that's not including data centers or server racks or RAM or graphics cards or anything else, or CPUs or anything that you need to power the servers, or electricity for that matter. So that number of $439.8 quintillion kind of makes the US debt look like chump change. So now let's go with the cheaper option, at least in cost per terabyte, which is the 24 terabyte hard drives option. So we already established that we need to account for 1.1 quintillion terabytes. So we basically do the same math, but rather than dividing by 100, we divide by 24, since now our drives have 24 terabytes rather than 100. And that gives us 45.8 quadrillion drives we need. So basically a little over 4 times more drives, just because we're going from 100 to 24, which definitely makes sense. If 24 is almost 25, 4 times less than 100, so, checks out. So then we multiply the 479.9 by that 45.8 quadrillion drives, and that gives us a grand total of roughly $22 quintillion, which is a huge cost savings compared to the $439.8 quintillion that the 100 terabyte drives would cost. But you also have to account the fact that we're using 4 times the number of drives, which means we would need to factor that into our overall cost, that being things like servers, server racks, data centers, all that good stuff that you need to factor in. Because I didn't run the numbers, I'm not sure if all those additional costs would completely eliminate the massive, whatever that is, over 400 quintillion dollars worth of cost savings. But I would think you'd probably still be okay. But like I said, I didn't do the math on it, so I can't say for sure. But yeah, I mean, you're still using 4 times the drives, which is definitely a lot. But we're also talking about astronomical numbers. So the last one I wanted to do just for kind of fun was just an estimate of a 32 terabyte drive, because that is soon to be the biggest that you can get. So I'm going to assume the price of one of these 32 terabyte drives is $600. That could be way off, or maybe that's spot on. I have no idea, but I'm just going to roll with it for this example here. So our math is basically the same as before. We take our 1.1 quintillion terabytes and we divide it by 32 to get the number of drives we need, and that gives us roughly 34.4 quadrillion drives. And then if we multiply that by 600, we get roughly $21 quintillion for the 32 terabyte option. So you save over $1 quintillion, which for context would be enough to pay down the U.S. national debt 576,444 times with some money left over. So, of course, we're talking about absolutely astronomical numbers in today's day, but it's wild to think that maybe in, I don't know how many years, this whole calculation would be laughable, that, it would have cost you that much money in 2025 to create have 1 million yottabytes. It's like, we get that in our laptops nowadays. Well, probably not, because they had to pay all that for like their data center. So probably not a million yottabytes, but who knows? They might be saying, oh, it costs you that much. Well, I mean, we have laptops now with exabyte drives or something like that. I don't know. I'm just spitballing here. But yeah, so those were some of the kind of things I just kind of wanted to nerd out on when I read the books again. Those were some of the things that really just jumped out at me. And we didn't even get to touch on the whole in firmware thing, where one of the AIs of Halliday's like dead AI spooking the system or whatever, like roaming the system, puts in a malicious firmware to essentially force everyone to stay logged into the system, which we didn't even get to touch on that, but we are kind of getting close to time here, so I am going to cut it short. But that is also another kind of wild thing, where some AI was basically able to overwrite the firmware that was going out to the headset consoles that the user were using to essentially trap them inside the simulation and basically make them hostages, which is absolutely crazy. It was basically able to override all the various safety precautions built into the firmware with his own malicious one. Absolutely mind-blowing stuff. But with that, let's get back to our trivia question before we wrap up this episode. So this week's trivia question is, how many terabytes are there in an exabyte? Now, if you were paying close attention to this episode, you probably should be able to work out the answer. So again, how many terabytes are there in an exabyte? If you said 1,048,576, congratulations, you got this week's trivia question correct. And also, if you didn't actually get that number, but you said either 10 to the 24 or 1024 times 1024, I will also accept that as a correct answer because they are all the same thing. So, yeah, that's going to do it for this episode. If you enjoyed it, definitely be sure to give it a rating and review and subscribe if you haven't done so already. And be sure to share it around with a friend or family member. And if you have any questions about this episode or have any topics or ideas or comments for future episodes, be sure to shoot me an email at contact@darkassassinsinc.com. Or if you're on YouTube, you can leave a comment down below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.